So in my previous post, I had posted that about a Zig Ludo game that I built, right? So it was built in, as I said, the Zig language. But this time I have built it in the Rust language, right? So basically, same. The concept is exactly the same. You have a four-player game. Each player is denoted by its own color, right? And then, I mean, there is a player object, but each player has is associated with a certain color, and each player has got four pieces which the player moves. Once the player hits a six, then he is allowed to move one piece, and once the any of the pieces of the player go to the end, then basically you can't move the piece because it has reached its destination. And then the player which is able to uh, put his pieces to the destination uh, before everybody else will win the game. So since this is a randomized algo, and the dice throw of every player is random, so for different executions of this program, different players will win, which is quite obvious. So now let us look at some of the structs which are there in this game, or even before that, let me just explain what is this in Rust. So basically we can clone an object, uh, right, and copy an object. I'll This is linked to ownership, which I'll explain a bit later. And debug helps us to print this particular struct, right? Let us look at this phrase struct. Phase is which phase the current game is in, or the current player is in, right? It can be in the rolling phase or moving phase or waiting phase, right? So there are three phases. There is a game state. So this is it consists of the player index, which player is currently will throw or is waiting to throw, and then what phase the player is in, right? And the dice roll that player has done, right? So this is the game state. This is an implementation of the game state. This implementation in Rust, what it does, it enables you to initialize this particular struct as an object. So we use this new, and what will be happening in new is mentioned here. So basically, once we write new game state, then the player index will be initialized to zero, phase will be initialized to phase waiting enum, and dice roll will be initialized to zero, right? I think I made a mistake. This is an enum, not a struct. So enum is written. I actually made a mistake. So you know what an enum is, right? It's pretty similar to enums in C++ and other languages, and even in Zig, pretty much the same. Yeah. So this is the p struct, which again can be initialized, right? So this is the piece of code which is responsible for this. And now let us come to the player struct, right? So player struct also has some variables which is initialized when this object is instantiated for a particular player. So there will be four instances of each belonging to each of the four players, right? And then there are three functions which are associated with it. Can move piece, right, which contains logic pertaining to what is generally expected from a Ludo game, right? I'll just try to try to attract your attention towards this particular line, which is a quite sleek piece of code. So what it does, it iterates through all the pieces, right, of self. Self is the player, right, the object of the player, which is referencing itself, right? And then if all the pieces are true, all the for all the pieces, if the end property of the particular piece is true for all pieces, then it returns true, right? So this is how you write the return or function in Rust. So after this arrow, there will be the return type. So bool is the return type. So this sleek piece of code and function does this. Basically says whether the player has won or not. That is the function of this. So this is dice roll. This piece of code generates a random number between 1 and 6, right? So this was slightly difficult to do in Zig, but it is pretty easy in Rust because it has already libraries which have functions which can do that pretty easily, right? There is one more thing about Rust is, like Zig, you have to mention that whether the variable is mutable or non-mutable, and the compiler enforces it. And even when passing the variable as a reference, you have to mention whether the reference is passed is mutable or immutable. If it is mutable, then you basically what you do is that you just aim to use it and not change it. And if it is mutable, uh, you would plan to change that, right? And that is enforced. So suppose if you have attached mutable to a particular object which is passed into a function, then you must change that object. Otherwise, the compiler will throw a error during compilation, right? So this is the main function, which is pretty much same as what was there in Zig. The logic is pretty same. So right now, coming to the ownership. So Zig, now, for explaining that, I think I should give back this line. So Zig has this ownership model, right? So every value has an owner, and when the particular owner gets out of scope, the value is deleted. And even if there are other uh, variables which are pointing to the value, they basically will now point to null. So so that's how ownership is implemented in Rust, which is pretty unique to Rust. It is not there in any other language. Rust has something called a borrow checker, uh, is which is responsible for implementing this ownership feature of Rust, right? So when you clone, you basically create another value, and then the new member, which is cloning the value from the old variable, gets the ownership of the new value. And for copy, he only gets to use it, but doesn't get the ownership. So again, if the uh, value which with the variable which the a new variable is copying from gets deleted, then the new variable will always not be able to use that value from further, because the old variable from which it copied the value from is deleted. And since the own variable, sorry, since the old variable had the ownership, so now the new variable will point to null, right? So yeah, so in my post, I'll give links to the GitHub page, and also this Rustlang online compiler, and a compiler environment of Rust, right? You can also run your Rust program here. And I'll also link to the previous video, a previous post which I posted on LinkedIn, in which I did the same thing in Zig. So with that, see you in another video.